Hi viewers, this is Sri Ramulu. Today's topic is PN junction diode. So please, before watching this video, please subscribe and don't forget pressing bell icon for getting more videos. So PN junction diode. When a P-type material is intimately joined to N-type, a PN junction diode is formed. Okay, so when P-type material is joined with the N-type material, then PN junction diode will be formed. A p-type and n-type semiconductor pieces before they joined, they are shown here. See, it is a p-type, it is n-type. Before joining, they have shown like this. Okay, so see in big size, in enlarged view, p-type this side and n-type this side before they joined. Now let us consider that two pieces are joined together as shown in figure. So like this, two pieces are joined. As p-type material has high concentration of holes and n-type material has high concentration of free electrons, and hence there is a tendency of hole to diffuse over n side and electron p side. So what is its meaning? P-type material has high concentration. Concentration means for the small volume. High means a large number of holes will present. Large number of, that is called concentration. Here, if you observe, in p-type material, high concentration of holes more present, and here high concentration of electrons means a large number of free electrons present. And when these two pieces are joined like this, then from n side, electrons are attracted with the p side, and from p side, holes are attracted with the n side. Then a recombination process will take place where these two pieces are joined. That region where the recombination process took place, that region we have to say depletion region. What is its name? Depletion region. So that is, I will explain here once again. Okay. The process is known as diffuse. Diffusion means either electrons or holes has to come from high diffusion region or high concentration to or high density to low density. That is called diffusion. Okay, electrons or holes has to move from high concentration region to low concentration region or high density region to low density region. That process here we have to say diffusion process. So due to diffusion, some of the holes from p side cross over n side where they combine with electrons and become neutral. Here diffusion, because of due to the diffusion process, what happens, these two are combined here. And next, and become neutral. Mean after combination, neutral means neither positive nor negative we get, that is a neutral. Okay, neutral means neither positive nor negative. Thus a region is formed which is known as depletion layer or charge free region. Charge free means no charges present there, that is the meaning of charge free. So no charges means either hole or electron cannot present there. The combined state we have, the region is a recombination or combined state of electron hole. Next, junction diode. When depletion layer is formed, there are negative immobile ion in p-type semiconductor and positive immobile ion in n-type semiconductor as shown in figure. And here negative immobile, which cannot move, that is immobile, or we can say a less number of things. Okay, in p-type or minority, in p-type majorities are holes and minorities are electrons. Majorities are holes and minorities are electrons. In n-type, minorities are in p-type majority holes, right? In p-type majority holes and a minority electrons. In n-type majority electrons and minority holes, like this. Now, due to charge separation, a voltage VB is developed across the junction under equilibrium condition. Now, due to the charge separation, so because of charge separation means here this side for towards the positive plate, negative charges will get, towards the negative plate, positive charges we get, so they are separated. Then what we potential barrier will be developed. Okay, so across the junction. Now due to the charge separation, a voltage VB is developed across junction under equilibrium condition. This voltage is known as junction voltage or internal voltage. So this voltage we have to say junction voltage or internal voltage. It is clear from the figure that potential barrier VB set up in this manner gives rise to electric field. So like this side negative and this side positive charge is present, and because of that potential difference created, that is called barrier potential or internal potential or junction voltage. And because of separation of charges, then electric field also generated. Okay, this electric field prevents the respective majority carriers from crossing the barrier region. Okay, so this field is what is it is doing, it is stopping the charge carriers to cross the region. So for example, in N type electron will present, these means electrons are majority charge carriers. These electrons cannot cross this region, so they here to stop its movement, to crossing movement through the depletion region, your electric field can oppose its motion. So this side also hole cannot cross this side because of electric field. The diode symbol is given electric field. This electric field prevents majority carriers from crossing the barrier. The potential barrier of order 0.1 volts to 0.3 volts. So here voltage is how much voltage develops here, 0.1 to 0.3 volts. Diode symbol, see here the diode symbol, this side is anode, this side is cathode, this side P type, this side N type. So like this. It is a P type, N type can be shown like this. Okay, P type and N type, and anode, cathode. Working, diode works in forward and reverse bias only. Forward bias. When an external voltage is applied to PN junction in such a direction that it cancels potential barrier and permits the current flow is called forward bias. What do you call forward bias? Suppose what I am doing, I am applying the voltage here, means increasing, means giving voltage across this PN junction diode. Then it cancel the potential barrier. So already we have shown this side potential barrier. See, potential barrier means that this is the region. So this region can be lowered when we increase potential. So this region slowly what happens, decreases this gap. Finally it becomes single, or it becomes cancelled. So to cancel what we have to do, we have to apply potential external voltage. Okay, when external voltage is applied to the PN junction diode, what it is doing in such a direction, it cancel this region. What region? Region is called depletion region, or its voltage is called potential barrier. And permit means it allow current flow, so current flowing will start. That is called forward bias. Here connection, the positive terminal of a battery is connected to P type of semiconductor, while negative terminal of battery is connected to N type semiconductor, as shown in figure. So here it is shown. So see clearly, P type, N type. It is in forward bias, means positive is connected to positive only, negative is connected to negative. What is negative? Negative terminal of the battery is connected to N type. Positive terminal of the battery is connected to P type. P means positive, N means negative here also. Okay, so it is called forward bias. And here it is ammeter, how much current is flowing through this junction diode can be read by the ammeter. therefore the potential barrier is reduced. Like this, the potential barrier reduced means minimized, so there are no potential will present. As this very small, therefore the small forward voltage is sufficient to completely eliminate the barrier. So just now as said, potential barrier is 0.1 to 0.3 only, almost voltage. But for, if you observe the for germanium and silicon, for germanium it is 0.3 volts, and for silicon it is 0.7 volts. Okay. When potential barrier when potential barrier is eliminated by forward voltage, junction resistance becomes zero. So here current is flowing means no resistance will present. Okay, so that's why junction voltage is zero. Now current flows across a PN junction like this. In case of forward bias, right? In case of forward bias, holes from P-type semiconductor are repelled by the positive battery terminal towards the junction, and simultaneously electrons in N-type semiconductors repelled by the negative battery terminal towards the junction. Here in forward bias, see here forward bias. So already we know this is a in forward bias, not this one. It is not diagram for forward bias. It is a diagram for forward bias. See. So this positive terminal, this is the positive terminal. So see, sorry, it is not. Okay. Now this positive terminal, what it is doing, it is a plus, and holes are also positive. So both positive, what happens, repel. So that is why charges moves inside, positive charges. And if it is negative, and it is also negative charge carriers, so then it can make to repel this charge particles, negative charge particles toward this side. So like this, this region becomes very small, then current starts flowing easily through the junction. That is the reason. So this diagram is for reverse bias only. In case of forward bias, holes from P-type semiconductors are repelled by the positive battery terminal towards the junction, and simultaneously what happens, in case of forward bias, holes from P-type semiconductors are repelled. Yes. Okay, just now. Here voltage should be high to impart sufficient energy to these carriers to overcome potential barrier at the junction and enable them to cross through it. Here voltage should be high. Here if you want to make it so that in forward bias, it is reverse bias diagram. In forward bias, if you want to make the current flow, then sufficient voltage we have to apply. So sufficient voltage means already junction voltage we have, that is a varies from 0.1 to 0.3. If you apply the more than this voltage, then what happens, current can easily flow through it. That is a sufficient energy that produces sufficient energy to the charge carriers. When electron hole combination takes place near the junction, a covalent bond near the positive terminal of battery breaks down. See, when electron hole combination takes place near the junction, covalent bond near the positive terminals of battery breaks down. Here, when electron hole combination takes place, so at the junction, then what happens, near the junction, covalent bond is a bond between electron and electron only, but here electron and hole combination is given. Electron bond will be broken down. This causes a liberation of electrons which enters a positive terminal, and this action creates a new hole from negative terminal of a battery, right? So here when we apply the voltage greater than the potential barrier, then what happens, they can they can break the bond between the electrons. That bond is covalent bond, and then we get large number of free electrons. So these electrons can make to flow the large. This electron can be shown by the ammeter, and later the current increases very sharply. This constant movement of electrons towards the positive terminal and holes towards the negative terminals produced a high forward current. So that is why. So just now electron hole pairs the bomb breaks, and then electron moves this side, and here hole will be created that moves opposite in direction. So like this electron hole pairs generation will take place. Now reverse bias. When external voltage is applies to the PN junction in such a direction that it increases the potential barrier, then it is called as reverse bias. So in reverse bias, what is happening when we apply the external voltage, potential barrier it increases. So the region, depletion region increases. So like this. Reverse bias. Reverse means negative terminal is connected to P type, positive terminal is connected to N type, like this. Okay. For reverse bias, positive terminal of the battery is connected to N type semiconductor, and a negative terminal of the battery negative terminal to the P type semiconductor. Okay. So positive terminal of battery is N type, and the negative terminal of battery is connected to P type, as shown in figure. Just now we have shown in above. The applied reverse potential establishes an electric field which acts in the same direction of potential barrier. Okay, in which direction potential barriers acts in the same direction, here electric field also acts. So that is why it makes to cross the electrons through depletion region. Therefore, the resultant field at a junction is strengthened and a barrier height is increased. So because of this having the both in same direction, what happened, they makes to do not cross the electron. So the gap what happens in between the depletion region gap is increases. Then electron cannot cross this barrier. The potential barrier prevents flow of charge carriers across the junction. Yes, potential barrier prevents means stops flow of charge carriers across the junction through the junction. In this way, high resistance path is established, right? So when electrons are not flowing, then what we can say, it has a high resistance, isn't it? When junction is reverse biased, electrons in N-type conductors and holes in P-type conductors are attracted away from the junction. Here see the diagram for this point. Here what? Here we have the holes. Positive charge carriers can be attracted with the negative one, and negative charge carriers can be attracted to the positive one. So that is why this gap what happens gradually increases like this. Okay. Then electron do not cross. Current flowing also stopped. So that means it can show high resistance path. Okay, next. Since there is no recombination combination of electron hole pairs, and no current flows in the circuit. So no recombination takes place. Why? Because they are attracting towards the battery. Okay, no recombination process takes place. Now, from the above discussion, we conclude that when PN junction is forward bias, it has low resistance path, and hence current flowing starts. Okay, so current flows in the circuit. So that means in forward bias, low resistance will be present. So that is where current flows, high current will flow. When it is reverse bias, high resistance path, it has high resistance path and no current flows in the circuit. So that is why when reverse bias, so depletion region increases. That is why high resistance present, no current will flow. Thus, PN junction diode is one-way device which offers low resistance when forward bias and behaves like a insulator when it is reverse bias. So in reverse bias, what it behaves? Insulator means bad conductor. In forward bias, it has low means a good conductor. So that means it allows the current in forward bias and in reverse bias it cannot allow. So that is why sometimes it can act as a switch, or we can say it is used to as a rectifier. Thus it can be used as rectifier. Rectifier means what? Converting AC current into DC current, alternating current into direct current. Next, very important is VI characteristics in this. VI characteristics means voltage versus current characteristics, means what happens, how the changes occurs. From figure shows that circuit arrangement for drawing voltage ampere current in the PN junction layer. When no external voltage is applied, the current applied the circuit current is zero. Okay, no, when there is no external voltage, no current will get. There are two characteristics for PN junction diode. They are forward bias and reverse bias. What are those? In forward bias, for forward bias of PN junction, P type is connected to the N type to the positive terminal, while N type is connected to the negative terminal of a battery. Yes, that is called, we know that is just now I have explained above, that is called forward bias. The potential at PN junction can be varied with the help of potential divider. It is called potential divider. So we can vary means change across PN junction. At some forward voltage, say here it is 0.3 for germanium, 0.7 voltage for silicon. So if you have the germanium diode, so just if you want to cancel the potential barrier enough 3 volt or just greater than 3 voltage if you apply, then depletion layer will be cancelled. For silicon, 0.7 voltage is required to cancel the depletion layer. Okay, beyond these voltages, current, what happens, current starts flowing in forward bias. This voltage is known as threshold voltage. We have to say threshold or cut-in voltage or knee voltage. So these are the three different names: threshold voltage, cut-in voltage, or knee voltage. It is practically same as barrier voltage VB. Okay, for V is less than Vth, current flow is negligible. Okay, so when it is more than the Vth, then only current flow starts. As the forward applied voltage increases beyond the threshold voltage, the forward current rises exponentially. So forward current rises exponentially, means at the beginning it cannot increase, and after a certain time what happens, it starts increasing the voltage like this in forward bias. It should be remembered that if the forward voltage is increased beyond the certain shape value, it produces extremely large current which may destroy the junction due to the overheating. If you continues the voltage increasing, what happens? After certain time, it will destroy the junction. Then diode cannot work. And see, this is forward bias diagram. So this is only forward bias diagram, so, but it is in reverse bias. In forward bias, see, current is taken along y-axis and voltage is taken along x-axis. This are negative current and negative voltage. Reverse bias. For reverse bias of PN junction, P type is connected to N type negative terminal, while N type is connected to positive terminal of a battery. Yes, reverse bias, a reverse connection will be implemented. The reverse potential at PN junction can be varied with help of potential divider. Yes, potential divider means, just now I said you, potential divider is, which is applied voltage is a potential divider. Okay, now the reverse potential at a PN junction can be varied with help of potential, right? In this case, junction resistance becomes very high and practically no current flows through circuit, right? So we know when N type is connected to P type, P positive terminal, then all electrons are attracted and holes attracted towards the battery. So then what happens, the depletion layer increases, then practically no current flows. In this case, what? Resistance is very much high. However, in practice, when in real life, a small current of order of microampere flows in circuit due to the minority charge carriers. Minority charge carriers means in p-type electrons are minority charge carriers, in n-type holes are minority charge carriers. So because of this very small current flows, that is in terms of microampere. This is known as reverse current. The reverse current is shown in the diagram. So here a reverse current is shown here. So these are the reverse currents. As the reverse voltage is increased from 0, the reverse current quickly rises to its maximum or saturation value. Here when we apply the reverse voltage, then what happen, reverse current also increases. Later it increases very much, very sharply. The slight increase is due to the impurities on the surface of the semiconductor, which behaves as a resistor and hence obey the Ohm's law. Okay, so impurities, because of impurities only, so slight increases because of impurity surface and behaves as a resistor. So on the surface of the material, what present impurities present. So when in the doping process we add the impurities, this gives rise to current called surface leakage current. So on the surface, small amount of current will produce, that is called surface leakage current. So because of impurities, this is independent of temperature. So it cannot depends on temperature, but it depends on reverse voltage. So as the reverse voltage increases, surface leakage current also increases. If the reverse voltage is further increased, kinetic energy of electrons, means minority carriers, become so high that they knock out electrons from the semiconductor atom. So here it is a what p-type material containing p-type containing electrons are minority charge carriers. Okay, when we apply the reverse voltage high, then these electrons come outside from the atom of semiconductor and can give large number of current in reverse direction. Now the junction destroy permanently. Now also junction can be destroyed, later we cannot use it. So in the forward bias also, when we increase more current, then also junction destroy. Here in reverse bias also, no more voltage has to apply. So less up to certain extent only we have to apply the voltage, and beyond it can damage the diode. Okay friends, here the very important in the examination, how the questions ask, explain PN junction diode, and they ask, and sometimes they ask uh, explain the VI characteristics of PN junction diode. Okay, explain the VI characteristics of PN junction diode. So friends, don't forget. So here important thing is VI characteristics only, not working. Sometimes they ask working. Okay, what is a PN junction diode? Explain its working. So sometimes they may ask like this for short question. For long question, VI characteristics they must ask. So that is why please keep in mind while listening or preparing this class. Okay friends, thank you. Here two questions are there in this chapter, so that is why it is a very much lengthened. Okay friends.